limit definition of the derivative, the alternate form in the trig review, lesson 1-4. Any non-vertical line has the same slope at every point. In calculus, we frequently deal with the slope of a curve. The slope of a curve is defined to be the same as the slope of the curve's tangent line at a given point. To find the slope of a tangent line, we need limits. And it's the limit definition of that slope of a secant line. So a derivative, one of the definitions is the slope using 1 point. So how do you find slope with 1 point? Well, you need a limit, because as it's approaching 1 point is what I'm looking for. Because when you get there, it is indeterminate. So here we go. Look here, 2 points is a secant line. A tangent line is 1 point. So in algebra, it is y2 minus y1 and x2 minus x1, or the change in y over the change in x. In calculus, we write this as a limit. As the change in x becomes 0, then we're using 1 point. So as we're approaching 1 point, that's what we're looking for. All right, turn the page. And we know there's shortcuts, right? We're going to talk about that soon. So first, here we are, different notations for derivative, including the slope of a tangent line and limit definitions of it. We're going to use this one with h. It says, for this function, find the derivative. And so we're going to use this as h approaches 0. And the setup is you plug in x plus h, and then you subtract f at x, and that's all over h. There's the setup. So in this situation, look at there, we're going to plug in x plus h, and we're going to square it, subtract, use parentheses, and then just plug in the function, and that's all over h. Now we have an algebra to do, because right now it's indeterminate. If I plugged in 0 for h, it would be indeterminate. So now we're going to expand. So expand this. This is x squared plus 2xh plus h squared. We still have a plus 2, and we subtract x squared and subtract 2. So now it's fully expanded. We're going to combine like terms and factor. We'll do that in one step. So x squared minus x squared, 2 take away 2. What's left? They both have an h in common, so we're going to factor out an h. And then we can cross out h. Now we have the ability to evaluate at 0, so plug in 0 for h, and you're left with the answer, which is 2x. And you might remember that there's a shortcut to use that, so you can confirm that the answer is 2x. Use your answer in part A to find this. So the derivative at -3, this is now the derivative equation for this equation. So we have a function and the derivative of the function. So plug that in for x, and you get the answer -6. All right, let's look at number 2. Y equals the square root of x. I want to find the derivative using a limit. So the limit as h approaches 0. We start with x plus h. So take out x and put in x plus h. Subtract the function, which is just the square root of x. And that's all over h. Practice. Next, we're going to use the conjugate, which is the square root of x plus h plus root x, top and bottom. Now, when I use the conjugate, the denominator, I'm just going to put them beside each other, but the numerator now is the difference of squares, which means I can go first times first. So root x plus h times root x plus h. First times root, just the square roots are removed, and you're left with x plus h. And then the last two terms, root x times root x, that's just x. I said the denominator, we're just going to put beside each other. What's going to happen is this, x take away x, they're done, and then the h's divide out, and you still have a 1 on top, and now I can plug in 0 for h, and so what I'm left with is root x plus root x, and if you like, that's 2 root x's, and now you have a formula for the derivative. Number 3. Again, we're going to take the derivative using limits. In this case, it's with respect to t. So make sure we're just going to use t when we do the limit notation. So first, instead of t, we're going to use t plus h. Subtract the function all over h. Now, for this situation, we're going to write it as one fraction. So we need common denominators. So to get common denominators, I'm going to multiply top and bottom times t, and I'm going to multiply top and bottom times t plus h. That way we have common denominators. So we have 2t. Now when I go negative 2 times t, I got 2t subtract 2t. They eliminate. So all I'm left with is negative 2h. And then again, the common denominator. Now, how do I divide fractions? I multiply times the reciprocal. So we have negative 2h, t plus h times t, and then the reciprocal, which is 1 over h. Notice the h's now divide out, so that discontinuity now is removed. Now plug in 0 for h for your answer. So negative 2 times 1 is negative 2. And if you plug in 0, we get t times t, so it's negative 2 over t squared. We do have an alternate form of the derivative if we're just finding the value at a certain point. So if I don't need the general derivative, if I just want the it at a certain point, there's an alternate form to use. It's right here, where c is that x value that I'm looking for. So if I want to find the derivative at 3, now it's a limit as x approaches 3. So as I get closer to 3, what's the slope? And then we have the function, which is x cubed, subtract. Then we put in 3. So it's f at 3. So 3 times 3 times 3. That's the difference of cubes. I'm going to help you out again. And then it's x subtract what we're going towards. So there is the alternate definition. Difference of cubes. It's x subtract 3, x squared plus 3x plus 9. Notice now it's going to be removed. Evaluate now at 3 and you get 3 squared plus 3 times 3 plus 9. That's 999. In German that would be no, no, no. And then 27. Here we go. Solving trig equations. Solving the following trig equations without using a calculator. Find all the solutions. This is the end of the lesson. Some trigonometry. We have to know our unit circle. Here we go. If I want to solve, and we're only solving from 0 to pi, so just one unit circle we're solving for. So cosecant x equals this. How would I solve for it? Well, one thing I would do is I would think of it as sine instead of cosecant, and then that would be the reciprocal, right? That's a good start. Sine is the y coordinate, and that means the x could be positive or negative 1/2. So there are two angles that could be. So now the question is, this is a 60-degree reference angle. The angle then would have a 3 in the denominator because it's a 60-degree. And then what quadrants are we in? So let's do that. So 1 pi over 3, it's not that quadrant. 2 pi over 3, this would be negative and positive. So it's not that one either. So it's these last two. So 3 over 3 we skipped. So this is negative, negative. So one angle is 4 pi over 3. And then the last one would be 5 pi over 3. This quadrant is positive, negative. So it's these two angles here that fit this. I know. It just takes practice. Cotangent is root 3. The definition of cotangent is the x over the y. So I want you to think of it as a fraction, and the x value is root 3, and the y value is 1, and then divide both by 2 so that you could see it on the unit circle. Now, this is a 30-degree reference angle. So I know the angle is over 6. Know that a negative divided by negative would also give you a positive answer. So there's two places. So in quadrant number 1, the answer would be 1 pi over 6. In quadrant 2, it's 5 pi over 6, 7 pi over 6, and then 11 pi over 6. In quadrant 3, it's a negative divided by negative. I don't know if you remember this, but all students take calculus. Uh-oh, my camera froze. Is it going to come back on me? That's okay. I might have to unplug it. Anyway, another way to find it is by writing down all students take calculus. Let's see if it's going to be unfrozen. I'll unfreeze it. Sometimes technology does this. Let's see if I can get this working again. All right, there we are. Hey, all students take calculus. This means all trig functions are positive here. Sine is positive, tangent is positive, and cosine is positive. And then you have to know what reciprocal matches up. So in this case, cotangent matches with tangent. So these are the quadrants that it's positive in. All right, let's try C. 2 cosine squared, subtract 1. I'm going to add 1 and divide by 2. When I square root, it's a quadratic, so the answer is positive or negative 1 over root 2. If I rationalize it, you would see it as root 2 over 2. Now, which angle is the x-coordinate, root 2 over 2? And the answer is, it's a 45 degree, right? And so what quadrants are we in? So pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. What quadrants is cosine both positive and negative in? And the answer is all of them. So we're going to pick every single quadrant, because 2 quadrants it's positive, 2 quadrants it's negative. So all of these angles work. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Last one, I'm going to factor this. So they have a cosine in common. And I'm going to take each one equal to 0. So the first factor equal to 0, and the second factor equal to 0. So I'm going to add cosine theta, and those are the things I'm looking for. So when is the x-coordinate 0? So that's either a positive 1 or negative 1. So when I think of the unit circle, that's going to be at the top of the circle or at the bottom of the circle. That's pi over 2 or 3 pi over 2. When I think of, what's the other one? A 1. So if the x-coordinate's 1, the only option is 0, and that's here on the right. So the other angle would be 0. So 2 pi is not included, so 0 would be the only one that I could add to that. And those are my 3 angles. And that's it. Mr. G Math over and out. I'm proud of you for doing the lesson with me, and we'll do the assignment right now. See you soon.